Okay, so that rule says, basically, let me state that first rule I gave you a little bit better because I didn't really like the way that was stated. If the degree of the numerator is actually greater than or equal to the degree of the denominator, then we can actually simplify this expression using long division. So let me just show you. So on that one, so here the degree 3 is greater than the degree 2. So we really wouldn't need to try to do this with the typical partial fractional decomposition that I did with the other examples. We could just use long division. Basically just divide the bottom into the top. So here I'm going to divide the denominator, x squared plus 2x plus 2, into the numerator, which is x cubed plus x squared plus x minus 1. And to do that, I say, okay, what times x squared will give me x cubed? And of course that's x. And then you multiply the x back. X times x squared is x cubed. X times 2x is 2x squared. And then x times 2 is 2x. Well, then you have to, remember with long division, then you subtract this. So if we subtract this, then we get x squared minus x squared is 0. And then x squared minus 2x squared is minus x squared. And then x minus 2x is minus x. And then you can bring down the minus 1. So now I have to say what times x squared will give me minus x squared. So that would be negative 1. So now multiply back. Negative 1 times x squared is minus x squared. Negative 1 times 2x is minus 2x. And negative 1 times 2 is minus 2. And so now I subtract again. So if I subtract that again, minus x squared, that would give me plus x squared. So minus x squared plus x squared is 0. And then minus x squared, and since I'm subtracting, I'd have minus a minus. So I'd have minus x plus 2x, which is x. And then for the same reason, I'd have minus 1 plus 2, which is positive 1. So the remainder term is x plus 1. So actually, by long division, I know that this actually will equal x minus 1 plus this remainder term, x plus 1, over the divisor, x squared plus 2x plus 2. So I can actually write this integral here of this fraction into two integrals, one integral being the quotient x minus 1, and then the other integral being the remainder, which is x plus 1 over x squared plus 2x plus 2. Okay? And then to integrate this, it's very simple. You know how to integrate x. You just get x squared over 2 and minus 1. You integrate that, you get minus x. Alright, but to integrate this one, you're going to actually have to use a substitution. So I could let the denominator equal u equals x squared plus 2x plus 2. Then du would equal 2 times x plus 1 dx. Well, I don't have I don't have 2 times x plus 1 dx, but I do have x plus 1 dx. So what you could do is you could, if I can get, let me get rid of this. You could take this expression and multiply it by 2, and of course on the outside you'd have to multiply by a half. So that would give me a 1/2, and now this numerator is du and the denominator is u, so I'm actually integrating du over u, and you know when you integrate du over u, you just get the natural log of the absolute value of u, and then the 1/2 of course has to come down. Whoops. Okay, I hit the wrong button there, sorry about that. So the 1/2 has to come down, and so you end up with 1/2 times the natural log of the absolute value of x squared plus 2x plus 2 for that integral. And then of course we already knew the other integral was x squared over 2 minus x. So there is your final answer to this problem right there. And if you want another problem to do for practice, you can practice on this problem and see if you can show that this problem is equivalent to breaking it up into the two integrals, where one integral is simply 2x dx and the other integral is 5x minus 3 over this denominator. And then you can actually break this up then you can take this and break it up using partial fraction decomposition. So you'll notice here I broke it up into integrals with x plus 1 and x minus 3, so I'm going to guess that this trinomial here actually factors into x plus 1 and x minus 3, and then you use partial fraction decomposition to figure out what the coefficient is for over x plus 1 and what the coefficient is over x minus 3. It looks like I got 2 and 3 there. And then once you get that done, then you can rewrite that as the sum of these two integrals, and you can just evaluate each of these three integrals, and there's the answer that I got down here for the final answer. Okay, now that's this is the third video on partial fraction decomposition problems, and so that's all I have for partial fraction decomposition. And so now we will go on to trigonometric integrals.